This Python code imports several libraries and initializes Plotly for offline use in the Jupyter Notebook environment. 1. The code starts by importing the pandas library, which provides data manipulation and analysis tools, and assigns it the shorthand alias PD. 2. The NumPy library is imported as NP, which is commonly used for numerical operations and array manipulation. 3. The calendar module is imported, which provides various functions related to calendars, such as getting the days in a month. 4. The plotly.express library is imported as PX, which is a high-level interface for creating interactive plots. 5. The make_subplots function is imported from plotly.subplots module, which is used to create subplots and plot multiple graphs in a single figure. 6. The plotly.figure_factory library is imported as FF, which provides several functions for creating specialized figures like heat maps, dendrograms, etc. 7. The plotly.offline library is imported as offline, which is used to initialize Plotly for offline use. 8. Finally, the plotly.graph_objects module is imported as Go, which provides low-level functions for creating graphical objects like traces, layouts, etc. The offline.init_notebook_mode, connected equals true, line initializes Plotly to work in offline mode within the Jupyter Notebook, meaning that plots will be rendered and displayed directly in the notebook. This Python code creates a bar chart using the Plotly library. It starts by initializing an empty figure object using the go_figure function. Then, it adds a scatter trace to the figure using the figure_add_trace method. The scatter trace represents the numerical values on the chart. In this case, the scatter trace has 4 points with x coordinates 0, 1, 2, 3, and y coordinates 1.6, 1.6, 1.6, 1.6. The mode parameter is set to text to display text annotations on the chart. The text parameter contains 4 HTML encoded text strings surrounded by tags. Each text string is wrapped in span style equals font size 33px tags to format it as bold text with a font size of 33 pixels. The text position parameter is set to bottom center to position the text annotations below the points. Next, another scatter trace is added to the figure for the labels of the x-axis. It has the same x coordinates as before, but different y coordinates 1.1, 1.1, 1.1, 1.1. The text parameter contains 4 strings representing the labels for the x-axis. The text position parameter is again set to bottom center. 2 horizontal lines are added to the chart using the figure_add_line method. The first horizontal line is at y coordinate 2.2, has a line width of 5, and a line color of gray. The second horizontal line is at y coordinate 0.3, has a line width of 3, and a line color of gray. The y-axis and x-axis visibility are turned off using the figure_update_y-axis and figure_update_z-axis methods, respectively. The layout of the figure is then updated using the figure_update_layout method. Several parameters are set, including the figure size, height and width, the title of the chart, its position, title_x and title_y, the x-axis and y-axis range, the background color, font size and color, and the margin of the chart. Finally, the resulting figure is displayed. This Python code is importing several CSV files into separate data frames using the pandas library. Let's break down the code line by line. 1. df_holy equals pd read_csv /input/store sales time series forecasting /holidays_events.csv. This line reads a CSV file called holidays_events.csv located in the /input/store sales time series forecasting /directory and assigns the data to a data frame named df_holy. 2. df_oil equals pd read_csv /input/store sales time series forecasting /oil.csv. This line reads a CSV file called oil.csv located in the /input/store sales time series forecasting /directory and assigns the data to a data frame named df_oil. 3. df_stores equals pd read_csv /input/store sales time series forecasting /stores.csv. This line reads a CSV file called stores.csv located in the /input/store sales time series forecasting /directory and assigns the data to a data frame named df_stores. 4. df_trans equals pd read_csv /input/store sales time series forecasting /transactions.csv. This line reads a CSV file called transactions.csv located in the /input/store sales time series forecasting /directory and assigns the data to a data frame named df_trans. 5. df_train equals pd read_csv /input/store sales time series forecasting /train.csv. This line reads a CSV file called train.csv located in the /input/store sales time series forecasting /directory and assigns the data to a data frame named df_train. This file likely contains training data for a time series forecasting model. 6. df_test equals pd read_csv /input/store sales time series forecasting /test.csv. This line reads a CSV file called test.csv located in the /input/store sales time series forecasting /directory and assigns the data to a data frame named df_test. This file likely contains test data for a time series forecasting model. Overall, this code imports multiple CSV files into separate data frames, which can be further used for data analysis, manipulation, and modeling tasks. This Python code performs several operations on a dataframe object named df_train, with the goal of merging it with other data frames containing additional data. Here is a detailed breakdown of each step. 1. df_train1 equals df_train.merge, df_holy, on equals date, how equals left. This line merges the df_train dataframe with the df_holy dataframe using the date column as the key. The merge is performed on the left side of the merge, meaning all rows from df_train are included in the result, and any missing values from df_holy are filled with nan. 2. df_train1 equals df_train1.merge, df_oil, on equals date, how equals left. This line continues the merging process by merging the result from the previous step, df_train1, with the df_oil dataframe using the date column as the key. Again, the merge is performed on the left side, so all rows from df_train1 are included and any missing values from df_oil are filled with nan. 3. df_train1 equals df_train1.merge, df_stores, on equals store_nbr, how equals left. This line further merges the result from the previous step, df_train1, with the df_stores dataframe using the store_nbr column as the key. The merge is again performed on the left side, so all rows from df_train1 are included and any missing values from df_stores are filled with nan. 4. df_train1 equals df_train1.merge, df_trans, on sadface date, store_nbr, how equals left. This line merges the result from the previous step, df_train1, with the df_trans dataframe using both the date and store_nbr columns as the keys. The merge is again performed on the left side, so all rows from df_train1 are included and any missing values from df_trans are filled with nan. 5. df_train1 equals df_train1.rename, columns equals, type_x, holiday_type, type_y, store_type. This line renames two columns in the df_train1 dataframe. It renames the type_x column as holiday_type and the type_y column as store_type. 6. df_train1 date equals pd to _datetime, df_train1 date. This line converts the date column in the df_train1 dataframe to a datetime data type using the pd to _datetime function from the pandas library. 7. df_train1 year equals df_train1 date.dt year. This line creates a new year column in the df_train1 dataframe that extracts the year component from the date column using the dt year attribute. 8. df_train1 month equals df_train1 date.dt month. This line creates a new month column in the df_train1 dataframe that extracts the month component from the date column using the dt month attribute. 9. df_train1 week equals df_train1 date.dt isocalendar.week. This line creates a new week column in the df_train1 dataframe that extracts the week number from the date column using the dt isocalendar.week attribute. 10. df_train1 quarter equals df_train1 date.dt quarter. This line creates a new quarter column in the df_train1 dataframe that extracts the quarter number from the date column using the dt quarter attribute. 11. df_train1 day_of_week equals df_train1 date.dt day_name. This line creates a new day_of_week column in the df_train1 dataframe that extracts the day name, example Monday, Tuesday, from the date column using the dt day_name attribute. 12. df_train1 2. This line displays the first two rows of the df_train dataframe. The to notation is used to slice the dataframe and only show the first two rows. Overall, this code performs a series of merges and transformations on the original df_train dataframe, creating a new dataframe df_train1 with additional columns computed from the merged data. This Python code generates a visualization of average sales analysis using a chart. Here is a detailed explanation of each part of the code. 1. Data preparation, df_st_sa, calculates the mean sales for each store type using the group B method, then sorts the results in descending order. df_fa_sa, calculates the mean sales for each product family using the group B method, then selects the top 10 values and sorts them in descending order. df_cl_sa, calculates the mean sales for each cluster using the group B method. 2. Chart color assignment, df_fa_sa, color, assigns the color number 496595 to the color column of the df_fa_sa data frame. df_fa_sa, color 2, assigns the color #C6ccd8 to the color column from index 2 onwards in the df_fa_sa data frame. df_cl_sa, color, assigns the color #C6ccd8 to the color column in the df_cl_sa data frame. 3. Chart creation, fig, creates a new figure using the make_subplots function with a layout of 2 rows and 2 columns. Specs, specifies the chart types for each subplot. Column_widths, sets the width of each column in the figure. Vertical_spacing and horizontal_spacing, control the spacing between subplots. Subplot_titles, sets the titles for each subplot. Figure add_trace, adds each trace, bar chart, pie chart, and bar chart, to the figure, specifying the data. And styling options. Row and col, specify the position of each trace in the figure. 4. Styling, figure update _*, updates the layout and styling options of the figure, such as axis labels, grid lines, ticks, margins, template, font, hover label, and legend display. 5. Display, figure show, displays the generated figure with the average sales analysis visualization. This Python code generates a bar chart showing the average sales for each month from 2013 to 2017. First, the code selects the relevant data from a data frame called df_train1 for each year, 2013 to 2017, and groups it by month, calculating the mean of the sales column. Each year's data is stored in separate data frames named df_2013, df_2014, df_2015, df_2016, and df_2017. Then, a new data frame called df_year is created by merging the separate year data frames based on the month column. The code sets some parameters for the chart, including the labels for the x-axis, the average sales for each year, and the colors for each bar. Next, the x-axis values are extracted from the df_year data frame and stored in x_data. The y-axis values, the months, are extracted from the df_2013 data frame and stored in y_data. A new figure object is created using the plotly library, and a nested loop is used to add a bar trace for each combination of x and y values. Each bar is given a specific color based on the year it represents. The layout of the figure is updated with various formatting options, such as the title, axis labels, colors, and legend. Annotations are added to the chart to label the y-axis and the different years on the x-axis. Finally, the annotations are added to the layout of the figure, and the figure is displayed. This Python code performs the following steps. 1. Computes the mean of the sales column in the df_train1 data frame, grouped by month, and stores the result in df_m_sa. 2. Rounds the sales values in df_m_sa to 2 decimal places. 3. Maps the numeric month values in df_m_sa to their corresponding 3-letter month abbreviations using the calendar.month_abbr list. 4. Concatenates the month abbreviation and sales value in df_m_sa to create a text label for each data point. 5. Computes the mean of the sales column in the df_train1 data frame, grouped by week, and stores the result in df_w_sa. 6. Computes the mean of the sales column in the df_train1 data frame, grouped by quarter, and stores the result in df_q_sa. 7. Sets the color values for the color column in df_m_sa and df_w_sa. 8. Creates a new figure with 2 rows and 2 columns using the make_subplots function from the plotly.subplots module. 9. Defines the layout and specifications of each subplot, including the type of chart, title, and position. 10. Adds a horizontal bar chart to the first subplot, using the go bar trace type from the plotly.graph_objects module. The data is sourced from df_m_sa. 11. Adds a pie chart to the second subplot, using the go pie trace type. The data is sourced from df_q_sa. 12. adds a line chart to the third subplot using the go, scatter, trace type. The data is sourced from df_w_sa. 13. Updates the visibility of the y-axis and x-axis in the first subplot to be hidden. 14. Updates the tick values and labels for the x-axis in the second subplot to display weak numbers. 15. Updates the visibility of the y-axis in the second subplot to be hidden. 16. Updates the layout of the figure, including the height, margins, title, font styles, and other properties. 17. Displays the figure using the show method. Overall, this code generates a 2x2 grid of subplots, each representing average sales analysis by month, quarter, and week. The charts include a bar chart, pie chart, and line chart. The figure is styled with specific colors, layout settings, and font styles. This Python code performs the following tasks. 1. It calculates the average sales for each day of the week using the group B function on a data frame named df_train1. The sales column is aggregated using the mean function. The results are stored in a new data frame called df_dw_sa. 2. The average sales values in the df_dw_sa data frame are rounded to 2 decimal places using the round function. 3. It creates a bar chart using the px.bar function from the Plotly Express library. The df_dw_sa data frame is used as the data source. 4. The bar chart is customized by setting various parameters. The y-axis of the chart is set to the day_of_week column from the df_dw_sa data frame. The x-axis of the chart is set to the sales column from the df_dw_sa data frame. The chart title is set to average sales versus day of week. The color of the bars is set to a light gray using the color_discrete_sequence parameter. The sales values are displayed on the bars using the text parameter. The ordering of the day_of_week values is specified using the category_orders parameter. The y-axis is customized to remove the grid lines, suffix the ticks with a space, and hide the line. The x-axis is hidden. The layout of the chart is adjusted with margin, height, and hover mode settings. The y-axis title is set to a space character to hide it. The color and font styles of the chart elements are specified. The background color and font style of the hover labels are customized. Overall, this code calculates the average sales for each day of the week, and then visualizes the results in a bar chart with customized settings. This Python code uses the Plotly Express library to create a scatter plot that displays the average sales based on 2 variables, store type and holiday type. First, the code calculates the average sales for each combination of store type and holiday type using the group B and ag functions. The result is stored in the df_st_ht data frame. The round function is then used to round the average sales to 2 decimal places. Next, the code creates the scatter plot using the px.scatter function from Plotly Express. The df_st_ht data frame is passed as the data source. The x parameter is set to store_type, the y parameter is set to holiday_type, and the color parameter is set to sales. The size parameter is also set to sales, which determines the size of each data point on the plot. The color_discrete_sequence parameter sets the color sequence for the data points. After creating the plot, the code applies various styling modifications using the figure update_ and figure update_ layout functions. These modifications include setting the y-axis tick suffix to a space, setting the height of the plot to 400 pixels, removing the x-axis and y-axis titles, setting the plot and paper background colors to #fafafa, setting the plot title font size and color, setting the font color for the plot, and setting the background color and font size for the hover labels. Finally, the figure show function is called to display the completed scatter plot. This Python code performs the following tasks. 1. It calculates the average sales for each combination of year, month, and store type using the group B method of a data frame object, df_train1. The result is stored in a new data frame called df_y_m_st. 2. The sales column in df_y_m_st is rounded to 2 decimal places. 3. It then uses the px.scatter function from the Plotly Express library to create a scatter plot. The x-axis represents the months, the y-axis represents the store types, and the color and size of the points represent the average sales. The plot is faceted by year. 4. The code updates the styling of the plot by modifying various attributes of the fig object. It adds ticks to the y-axis with empty space, ticksuffix equals, sets custom tick values and labels for the x-axis, sets the height of the plot, removes the axis titles, sets the margins, and specifies background colors, font styles, and hover label properties. 5. Finally, the fig object is displayed using the show method. This Python code generates and displays a scatter plot using the Plotly library. First, the code starts by calculating the mean sales for each combination of month and holiday type using the group_b and ag functions. The result is stored in a new data frame called df_m_ht. The sales values are then rounded to 2 decimal places. Next, using the Plotly Express library, a scatter plot is created. The data frame df_m_ht is used as the data source. Month is set as the x-axis, sales is set as the color, holiday_type is set as the y-axis, and sales is also used to determine the size of the markers on the plot. The color_discrete_sequence parameter sets the color palette for the plot. The title of the plot is set as average sales, month versus holiday type. After creating the plot, some styling options are applied. The y-axis labels are given a space at the end by modifying the y-axis properties. The x-axis tick values are set to be the numbers 1 to 12, and their corresponding tick text is set as the abbreviations for the months. The height, x-axis title, y-axis title, and margin of the plot are also modified. The plot and paper background colors are set to a light gray shade. The font size and color for the plot title and general text are modified. Finally, the hover label displays a light gray background with a slightly larger font size when hovering over data points. Finally, the figure show function is called to display the plot. Most of the sales were done in transfer holiday, and that to be in Christmas holidays month December and January, and pre-Christmas November month and May month showed a great trend in shopping. Let's take a closer look towards year and holidays type with sales.